Hi, welcome back. In the last video, I looked at configuration. Today, I'm covering something critical for production system. How do you handle failure gracefully? In the distributed systems that call external APIs, failures are not exceptional. They are expected. So the question isn't if an API will fail, but when. How I handle this failure determines whether my system degrades gracefully or crash spectacularly. So I'm going to cover the exception hierarchy, circuit breaker, pattern implementation, retry logic with exponential backoff, graceful degradation, really cool example. So I'm going to start with exception hierarchy. If you look at my code here, I have here the base exception here, which is the agent hub exception that all my custom exception inherit from. And if you look at below that here, I have specific exception types for different failure modes. Why this hierarchy? It gives color control over how specific they want their error handling to be. So if you look at here, this is a so from here, for example, here, when we have like a LLM, you can catch a LLM provider specific exception. So this specifically to undo LLM failure, which is different from connection failure, or you can catch the big exception for general error handling. So this matters in practice. For example, LLM rate limit errors should trigger a retry. So, and automated error shouldn't. So a natural timeout should activate circuit breaker. So if you look at here, I'm going to show you like, I'm just trying to explain the reason for different exception mode that we need to manage efficiently in the application. And when we are talking about the circuit breaker, the circuit breaker pattern prevent a cascading failure. And let's look at the problem itself. Let's say your system calls an external API. That API goes down. Without a circuit breaker, every request to your system still tries to call that API. Imagine. So each attempt to wait for a timeout before failing. So your system becomes slow, user get impatient and refresh, creating more requests. Now you have a queue of requests all waiting to timeout. Eventually, the system might crash. So the circuit breaker solved this. If you look at the code here, where I implemented the circuit breaker in the code. So if you look at it here, if you open this file, you're gonna see different kind of our custom error classes that I created here. You could just go through them, and if you look at it, domain specific agent error, right? Session error, workflow error. And now, as I'm talking about the circuit breaker, the design for circuit breaker here, you could look at it. I put a well written comment. Everything is well documented. I try to put comment at every section of the code so that you could understand it more efficiently. So when you look at a circuit breaker, what does it mean when you have this? So the circuit breaker has three states: the close, open, and half open. So close means everything is working, so request goes through normally, but I'm counting failure, right? So when failures exceed my threshold, the circuit opens. Now, request fail immediately without calling the external API. So you could actually try to control it. So look at failure threshold, look at a failure window, look at recovery time. You could change this configuration. You could actually move it to the YAML file as I previously explained, so that you injected the config. But because this is just a pure class, that is why I decided to do it this way. So and after a recovery timeout, it will, when a failure exceeds the threshold, the circuit open. Now request fail immediately without uh, calling the external service. So this gives that service time to recover and prevent my system from wasting resources on calls that will fail, right? Because I just want to wait when the service is ready. So after a recovery timeout, I enter a half open state, right? If you look at all the implementation I did here, just go through the code. The code is well documented. So the half open state, I try one request. If it succeed, I close the circuit. If it fail, I stay open, right? Check it here. So count as failure. I have a lot of implementation I should attempt to refresh, transition to open, right? Transition to halfway open, transition to close, right? These are the different circuit breaker functionality that I. So now looking at this, not all failures are permanent. This is why I have a retry logic that I also implemented here. This is the configuration for my retry mechanism. So, for example, when we see network hiccup, rate limit are transient, that's where retry logic help. So this is the code for the retry logic. If you look at it, you could go through it. If you have any question, you can pose the question in the comment section. I'm gonna reply to you, or you could just talk to me through my email address provided as well. If you have a specific need, or you need me to provide a better understanding, or if you need to just post something, I'm going to respond to you. When we are talking about here, exponential backoff. Why exponential backoff? So why the exponential? So the objectives, if you look at it, I also put some comment there. If an API is getting hammered, I don't want to make it worse with aggressive retries. So exponential backoff gives it a burdens room. So it gives it some sort of delay before it's going to retry it again. So notice I specify which exception trigger retry. So like rate limit errors get retried. So authentication error, don't do that. So if your API key is wrong, if you look at it, just check. If your API key is wrong, retry won't help, right? If you come here, this is like a retry when I'm trying to talk to the LLM, right? This is trying to retry. So when a preferred service is unavailable, the system call for back to alternate. That is if we have such. So, and this pattern ensure that a system remain functional even when individual component fail. Maybe if you have some sort of, one system is not available, you need to have like a alternative. So if you look at this code, this is where I use some sort of a resilience service. I use at retry with backoff, try to specify how many attempts. So, and if you look at here, here, I specify different, I specify which exception triggers retry. For example, rate limit, get retried. Authentication error don't, because there is no reason for authentication error is authentication error. You don't have to retry. Not that the external service is down or the external service is busy with some workload. So if your API key is wrong, retrying won't help you. So it's gonna stay the same thing if you keep retry it over and over again. So if you look at this pattern here, actually using like a decorated pattern here. I'm using a decorated pattern here. So now this is where it gets elegant. I use a decorated pattern to eliminate repetitive try and catch. For example, here, look at here. Without a problem, without a decorated pattern, right? I'm gonna have like a try and catch. This is try and accept, try and accept. However, with decorated pattern, right? I only need to do at retry mechanism, right? At retry async, right? At retry async. I put this an exception here. So this is elegant. And looking at it, this is cool. So you don't have to have like a try and catch for all the error. If you look at the decorator implementation, is also here. If you check the code, you see it in the code. Look at it in the core aspect of the application. If we come to the resilience, then you see resilience and you see retry. This is the real code I put it. So you can go through it. If you have any problem or anything, then you should let me know. For example, if you go to like um, so if you go to any of the implementation I did, you see that there I put a lot of comments there for you guys to really understand the implementation. So if you look at some of the implementation I did, if you look at it like in the memory catch, you see how I did like a undo catch error. This is like a decorator. So, and if I do this undo catch error, use it without this, it means that I'm going to have like a lot of code, maybe try and catch everywhere, right? So with this, it make it easier for me to be able to manage the exception. So if we check, let me try to search for this service. Yes. So guys, the objective of this is for us to be able to manage the application exception, retry, and having like some sort of exponential backoff so that you keep the system more efficient. And this is the resilience in the agent hub. In the next video, I look at the LLM provider abstraction layer and how I support multiple LLM provider with a single interface. See you in the next one. Thank you.